Hello Professor, so this is the video explanation for our project. Our project was to identify, develop an algorithm which can identify dogs in the image. So we did this project in 8 steps. So the first step was to import dataset. So we already downloaded the dataset and put it in the train, valid and test folders, and we used this piece of code to load these datasets into the Jupyter notebook, and we put all the names of the dogs into the dog names list, and we can see there are 133 total categories of dogs, and there are 8,351 total dogs. So the next task was to import human dataset. So here we are importing the human faces into our Jupyter notebook. So the next task was to detect human faces in the image. So for this task we used OpenCV implementation of HAR feature based cascade classifier to detect human faces. So this classifier is available on GitHub as a XML file. So we downloaded this XML file and put it in HAR cascade directory. So we are using this piece of code to load this XML file into our Jupyter notebook, and then we loaded a human image into BGR color category, and then we converted the BGR into the grayscale for our classification, and then we are using this piece of code to highlight the human face in the image. So you can see the output over here, and this is the highlighted part. So the next task was to write the face detector function, and so this function takes the image and it returns if the human face is detected or not. So we tested this human detector on our dataset. So ideally we were expecting 100% human images in human dataset and 0% human faces in dog dataset. So but you can see that our algorithm has detected 11% human faces in dog dataset, I think, which is acceptable. So we didn't do anything further. So next task was to detect dogs. So for this task we used ResNet. So this ResNet model over here is only detecting dogs in the image. So it won't return the breed of the dog, but it will only return the if the dog is present in the image or not. So for this task we uh, converted the normal image into the 4D tensor, and you can see how the 4D tensor looks. So here for 2 to 4 into 2 to 4 is the size of the image, and 3 is the RGB category. So we are making predictions using the ResNet 50 model over here, and we wrote the dog detector function over here, and this detector function takes the image and returns true if we detect a dog. So we have tested this dog detector function, and we got the result as follows. So there are 0% dogs in the human pictures, and there are 100% dogs in the dog pictures. So next task was to develop CNN which can classify the breeds of the dogs. So first we tried it developing from the scratch. So first we pre-processed the data into the valid size. We divided every file by 255. So next we used these layers. So you can see we used sequential model, and then we used convolutional 2D layer, then max pooling layer, then again convolution layer and max pooling. So these layers are used. You can see the dropout over here. We are dropping the neural networks by 2%, and we are also using global average pooling. So these are all the images layers that we used, and you can see the model summary over here. Then we compiled our model, and then we trained it for the 13 epochs, and for every epoch we save the model uh, in the save model folder, and then after saving the model after 13 epochs, we loaded it, and then we tested it with our testing dataset, and we got the test accuracy of 7.296%, so which is not acceptable. It is very poor. So we went ahead with the transfer learning. So we already downloaded the bottleneck features of VGG16 model, and we put it in the bottleneck feature folder, and we you can see over here we are using these functions to split the model into the training and valid and test sets. So we added our global average pooling and dense layer at the end of the VGG16 model, and then we compiled it, and then we trained it for the 20 epochs and saved it after the 20 epochs, and then we tested it, and we got the accuracy of 40%, so which is good as compared to our model, but it is still not acceptable. So we went ahead with another model, which is ResNet 50 model, and we downloaded the bottleneck features of that model also, and we split the model into 3 sets, and then we added these layers to that model, which is global average pooling layer, dense layer and dropout, dense layer and again dropout, and dense over here. Last layer has 133 nodes to identify the 133 categories of the dog. So we compiled the model, and we trained it for the 30 epochs, and we saved the best weights, and then we loaded it and tested it on our testing dataset, and we got the accuracy of 76%. So ResNet performed very well against the VGG16 and our implementation. So we went ahead with the ResNet model, which we saved after training. So you can see the training over here, and then we went ahead with writing the algorithm, which can detect the dogs and humans, or if nothing is present, it returns that this image may not contain human or dog. So this is the implementation of our algorithm. So this is the function which gets a file path of image, and first it runs a face detector function, which I explained earlier, and if it is not true, then it returns a dog detector function. So we tested this algorithm on the on some images. You can see these are the images that are present in image folder in our computer, and we converted these images into the suitable size and color, and then we use the detect image function, which we wrote over here, to get the output. So you can see the breed of the dog we got from our model, which is ResNet model, and you can see the breeds over here, and this is we tested it in on an image which doesn't contain human or dog. So we got this result as this image may not contain dog or human. So you can see all the results over here. So here we have only a human, and it returns a hey human output, and it predicts the closer looking dog to this image. So you can see all the results over here. You can also see that this image has a human face and dog face. So it detects that this image contains both of them, so it says human with dog of breed English Cocker. So this is our implementation. I hope you like it. Thank you.